Hello everyone. Today's topic is quadratic equation. So first of all, we will know what actually a quadratic equation is. So an equation in the form of ax square plus bx plus c equal to 0 and a not equal to 0 is known as a quadratic equation. So you will question me that it is okay, the form is ax square plus bx plus c equal to 0, but why this a not equal to 0? So this is an equation which is actually a quadratic equation in single variable, because here x is the variable and here we can see that there is only a one variable present here. So this is a quadratic equation in single variable. So you will say me ki why a not equal to 0? So I can say you, in ax square plus bx plus c equal to 0, a, b and c can be any real number. Any real number. Real number means what? Positive integer, negative integer, whole numbers, including 0. So b and c also can be 0. Suppose in this equation you say b equal to 0. What the equation will be? B equal to 0, then the equation will be ax square plus c equal to 0. Will it be a quadratic equation? Of course yes, because in case of quadratic equation, the variable is to be raised to the power of 2. So x square is needed in the equation and b is the coefficient of x. So when b equal to 0, the equation becomes ax square plus c equal to 0. So this is also a quadratic equation, no problem with that. Now if you take c equal to 0, what will be the equation then? Ax square plus bx equal to 0. There is also no problem because ax square plus bx equal to 0. This is also a quadratic equation. Now you will take, suppose b and c both are 0. What will be the equation then? Ax square equal to 0. This is also a quadratic equation. But in case of a equal to 0, the equation will become what? Bx plus c equal to 0. So this will not be a quadratic equation. This will be a simple linear equation. Because bx plus c equal to 0, here if we take this much part only, bx plus c equal to 0, then x, the power of x is 1. So this is a linear equation. This is no more a quadratic equation. So always remember that the forms would be ax square plus bx plus c equal to 0, and you always have to mention that a not equal to 0. I think clear till now? Now next part is the root of the equation. We know that every equation has a root. Suppose take alpha be the root of this equation. Which equation? X square plus bx plus c equal to 0. The standard quadratic equation. This is the standard form of any kind of quadratic equation. So suppose alpha be the root. Then if alpha is truly the root of this equation, ax square plus bx plus c equal to 0, then alpha will definitely satisfy the equation. That means in place of the equation variables, if you put alpha, this will give the exact value as the equation gives. So if we put alpha here, the form will become what? A alpha square plus b alpha plus c, that is equal to 0. So this is also equal to 0, this is also equal to 0. That means it is satisfying the equation. So we can say yes, alpha is the root of this given equation. So take a real case. Take an example. X square minus 3x plus 2 equal to 0. This is our example. And let's take the root, that is alpha be 2. Then if 2 is truly the root of the equation x square minus 3x plus 2 equal to 0, what we need? What we need? We need 2 to satisfy the equation. So let's put as this. That means alpha square minus 3 alpha plus 2 equal to 0. Here alpha equal to how much? Alpha equal to 2. So let's put here 2 square minus 3 alpha, and that means 3 into 2, 6 plus 2, that is equal to how much? 4 minus 6 plus 2, that is equal to minus 2 plus 2. Minus 2 plus 2 equal to how much? minus 2 plus 2 equal to 0. X square minus 3x plus 2 equal to 0. And here also alpha square minus 3 alpha plus 2 equal to 0. So, is 2 satisfying the equation? Yes, we are getting 0. So, we can tell yes, 2 is the root of the given equation, that is x square minus 3x plus 2 equal to 0. Okay, I hope you have found it helpful, and this all for today. In next video, we will try to discuss some problems from this chapter and try to solve it. Thank you and have a nice day.